Good morning, good afternoon, and good evening to all the viewers out there and who's watching this talk show, Friday talk show, I would say, with Global Electronics on electronics manufacturing. Every week we bring in a special topic, a different topic, which are basically connected to the electronics manufacturing, whether it can be designing, whether it can be manufacturing, the processes, the quality, the supply chain, and the market trend. So this is your host Rajiv Kulkarni with Global Electronics YouTube podcast every Friday, and welcome to the show. Last week we couldn't do the show because we had a severe power outage due to the Mother Nature's effect. With that said, first of all, we need to congratulate ourselves because we complete 1 year last week and of the inception of this particular channel, and there are a lot of people who are being very supportive in supporting the channel, and thank you so very much. And also the audience, you people are one of them who are supporting and always been a supportive people, because without you this channel can be very challenging, and also to run this show can be very challenging. This is a very non-commercial channel because we try to bring in the electronics talks, the electronics to help the electronic community out there, whether it can be based in US, in India, in China, in Malaysia or Europe, or we don't know what part of the world the people are watching this show. So welcome to the show. And today's topic, again, we are talking about the V model. And for that, we have definitely the veteran in the electronics designing, I would say, in the PCB design or anything related to the electronics manufacturing process, Mr. Amba Prasad, who is highly experienced in this field, who is based out in Silicon Valley of India, which is called Bangalore, in Karnataka state, which is the southern state of India. And Mr. Amba Prasad, welcome to the show. And how are you this evening?
Yeah, congratulations for the first year completion.
Thank you very
So,
much, and thank you for also contributing. Ladies and gentlemen, I just want to add one thing here. Mr. Amba Prasad has been a very supportive individual, professional, I would say, who has contributed to our shows on a weekly basis, and he has tons of materials to download, I would say, from his learning experience, and that is why we are associated with him, so that we bring in new topic that Amba Prasad carries in his brain of library of the wealth of knowledge, I would say. Yes, please, Mr. Amba Prasad, please continue.
yeah, let's start.
Okay, so we will start with, I will try to share the screen here with the presentation that we have. And uh, I think you are able to see the screen. And
I can see double screen here. You have
oh,
to
double
share
screen.
the PPT.
Okay, just one second. So I will share the screen here. Share. Okay. Okay, so this is where
Yep.
we left,
Go
I
to that
believe.
arrow and top
Yes.
right and enlarge it.
Yes.
Page 49.
So
Yeah.
this
Yep.
is the slide where we stopped in the last discussion of our V model. So before we proceed, Mr. Amba Prasad, tell the audience what is exactly the V model, and then we can proceed.
Yeah, V model is where in the subsequent slides we showed previously also. V model is on the left side of V. We spec things and we see set of specifications and the workflow is defined. And on the right, it is validated. So that what happens is the bottom of the V is the business end. That is where you have to really execute. So I can give you just an example. You go to next page, please. So this is a typical, it is used in software development, but people are using in all sort of things now, especially automotive electronics and aerospace, they're using it. And even in ultra high density interconnect, we are using. So Rajiv, if you remember,
Yes.
uh, 90% of the Indians have seen the film Sholay.
Yes.
And another 25 to 30% of the world of a particular age, they have seen Sholay. There is a famous statement in that movie. The jailer says, uh, those who are on the left side go to the left, those who are on the right side you go to the right, but
Yeah.
the remaining follow me. He says, half you go left, half you go right, and remaining
Yes.
follow me. So 50 years
Yes.
back, this looked very silly. People laughed at it and threw coins at it. But
Yes.
today, on the left side, you specify and you put your workflow, you put everything in place, your simulation, everything. And on the right side, you have validation. But now what is left? The execution. That is what will follows you. So that follows you till the end. If execution is not correct, the V model becomes just a, a some sort of a marketing talk and doesn't
Yeah.
take anywhere. That's why we have shown very clear. The bottom of the V
Yes.
uh, applied to ultra high density we have taken and have given the materials and stack up validation before design starts, microwire formation and microwire proofing, statistical process control and process capabilities, again validation and evaluation, and test vehicles. Test vehicles are very much important. Metrology. We should be able to measure what we have designed. If we cannot
Correct.
measure what we have designed, it goes nowhere.
Right. Right.
So made it extra large and put less material in the same place so that people can see. Uh,
Yes.
Bottom of the V model, as I said, it is the business end of the designers, at least designers like me. Material selection, it starts with material. Even with before the schematic starts, the material selection is frozen and it is booked. Material set selection, validate dielectric, copper foil, and resin flow, and adhesive systems for laser durability, everything. And then electrical properties like and thermal properties, especially when you assemble, when you go for a 6-time reflow, it should not delaminate and it should not get material should not degrade. That you do it. That generally people do it on a coupon. And stack up lock layer counts, foil weight, layer buildup, and sequential laminate cycles, simulate planarity. Actually, the delamination is a very big threat due to material and due to layout density. All layouts cannot be uniformly dense. There will be some hot spot, there will be some dense areas in some region, there will be sparse areas in some other region that will lead to warpage. And z-axis expansion. Actually, z-axis expansion is 5 times that of x and y eh, expansion or contraction, in which way you take it. So here what happens is that it is more severe. It can lead to lead failures and via failures if it is not controlled. Then thin core constraints, establish minimum core thickness, aspect ratio limitations, and bow and twist tolerances under lamination cycle and even in under assembly. So this has to be validated using a digital twin on the left side of the V before the design starts. But in the bottom of the V, whatever we got, we implement it.
Okay.
Uh, Here I'm taking a typical use case of a 448 Gbps SerDes channel. Actually, I can take this because 448 Gbps is yet to be implemented. It is going to be implemented. It will be available in a physical form. The PCBs will be available by 2027 or maybe little 3 or it take 3 or 5 months earlier. It may be available. IEEE calls as a 400 Gbps, but certain other MSAs are calling as a 448 Gbps. Generally, when you say 448, that 12% is the overhead. Whether you say 400, if you lose 12%, whatever, you'll end up somewhere. That's why people hype it to 12% extra overhead. Even when we say 112 Gbps, it's actually 100 Gbps. So the 12% is the overhead. Yeah, okay. That's they do. PCB technology, yeah, the PCBs may look like that because server class PCBs are really wide and they are really deep. And again, you may go for a co-packaged optics, which I have shown on the right side. And again, in fact, now we don't do any PCB routing. Directly, cable will start from the GPU or XPU. It will land in the faceplate directly. Or you may go for a co-packaged optics, but all these are available in 2027.
Wow.
Yeah. Uh, Having decided to go for a co-package because a PCB technology is now is there. I shown PCB on one side and co-package optics on the other side. PCB, I think we have covered enough since last 1 year. So let's go for co-package optics. Co-package optics, this is a typical co-package optics which is available through MSA, OAF. 3.2 terabit payload optical module for co-package optics. And then you can see the cross section of the PCB at the bottom. There is a host PCB, then the package sits on that. Now the cables are going directly from the package to the front panel. There is no PCB routing. You cannot achieve 448 Gbps by trace routing. It's not possible. Yeah, now having decided to go for a co-package optics, still the PCB has to be designed. PCB will generally give power supply and the physical support to the socket. Feature formation and reliability baselines. Microwave formation window, design of experiments, go for a laser drill, and you have to do desmear, then etch and capture the pad geometry. Now, pad geometry, what they do, capture pad, generally in a high density interconnect is slightly oversized so that it is more reliable. So they go at least 10% more than what your simulation gives or what your calculation gives. They go for 10% more size at the diameter. Then wire reliability, ISS stress test and TCT for stacked and staggered wires. Quantify fatigue under thermal cycling and current loads. Include corner cases, nested stacks and via in pad. This via and pad, some companies like via and pad, they spec it, we have to use. But there are certain companies, they say via and pad, they don't follow this. It is very strict. So basically, if you get a design, don't get into via and pad blindly because we have done for somebody else. We should not repeat for somebody else. Check to the OEM and ODM. Some people don't like via and pad because let's say we have a BGA, we have a socket or a BGA. Under that, the via is capped. So the PCB fabricators are giving 98% number of vias will be capped and planarized, no problem. But still, there is a threat that the cap may move, it may get disentangled. These are the perceptions, you know. That's why yeah, people do it. And again, as the PCB, as the BGA becomes larger and larger in size, this thread becomes now what works for a something like a say 20,000 pin BGA may not work for a 40,000 pin BGA. Now 40,000 pin BGA can be 8 times much complicated than let's say to a 20,000 pin BGA. It's like that. Conductor integrity.
Sorry.
No, just conductor integrity, line and space capability mapping, undercut roughness and plating uniformity, correlate to impedance control. Actually, now IPC 6012F aerospace addendum has come out with a new. Generally, people were talking about 20% reduction in cross section, and many people interpreted it wrongly. So actually, though it is for a cross section, people took it as a width, and a lot of PCBs failed. But IPC this time made it very clear how it is. In 6012F, it is come down to 15%. And so in fact, I professed 10% 20 years back, but people laughed at me for overspecking it. But I analyzed it. But 15% class 3. And if you go for aerospace addendum, it is what the customer says. What customer says has to be delivered. No questions, no ifs, no buts. It has to be done, and they are ready to pay the premium for that. So that's what it is.
Correct.
And CAF and insulation robustness, surface insulation resistance that happens in layers, external layers. CAF will happen in inner layer. And worst case basis, humidity, temperature profiles, verify resin systems and glass tiles for Ultra HDI pitches. Ultra HDI pitches right now for a mechanical drill it is 0.8 mm, but all server class PCBs, GPUs, they're gone for a 0.65 diagonal pitch. So 0.65 diagonal pitch will give you 0.9 if you calculate, if you do the math. So that way, because the servers are built for 15 to 20 years of life, so they want to a bit of a robust design. So that's what it is. The next slide, please. Process window characterization. Sequential lamination, map cumulative lamination cycles. Because once we go for Ultra HDI, there can be 2 plus n plus 2 or 3 plus n plus 3, 4 plus n plus 4, these kind of stack ups are used. So you have to cumulative stack up cycles. You have to go ahead, press profiles, resin flow, reflow margins, and dimension of stability. So this we have to take care, because on the PCB we may have a 40,000 pin socket on one side, and next to that we may have a 8 pin thermal sensor IC. So both we have to, I mean, that is a dichotomy of the electronic design. You have a ultra high density package, sitting that to next is a power supply or some current sensor or a temperature sensor, which is still a PTH, which is never went out of market. So both have
Correct.
to work together.
Yes, that's right.
Laser to copper registration, statistical process control on capture pad accuracy versus panel expansion, define compensation models for artwork and drill programs, especially in
Yeah.
the first article. Now there are two first articles,
Yeah.
VFA and PFA. VFA is a virtual first article, which is just a digital twin. Otherwise, there can be a physical first article. So both will be there.
Okay. Okay. Great.
Surface preparation and metallization, cleanliness, electrolysis, copper and DC plating for uniformity in microwire barrels and blend and buried vias. Set minimum plating thickness with tolerance bands, solder mask and finishes, validate mask registration over ultrafine pads, assess ENIG or ENIPIG or OSP. A new surface finish has come as ASIG. A couple of only two companies are able to give that, but that will become very popular in RF boards and high-speed boards. So that's also coming. You have to just, you have to validate it for intermetallic growth and contact resistance. Next. Yeah, I think, can we take a break, or we can take a break after this slide?
We can take a break and come back. So I'll
Yeah,
stop
that's better.
sharing here.
Yeah, yeah.
And so I wanted to let the viewers know that Global Electronics is engaged to bring in various types of topics related to the electronics manufacturing. So your help in sharing our channel link with your colleagues and also your friends and contacts makes a big difference. And also we request you to kindly subscribe to the channel, so that more subscribers means more viewers. Here we take a break and we'll come back. Welcome back. Good morning, good afternoon, and good evening, and welcome to the Friday Talk Show with your host Rajiv Kulkarni. We bring in this particular show every week with the different topics with different guests, and Mr. Amba Prasad has been a consistent guest for us most of the time. It's because he carries wealth of knowledge in the electronics manufacturing area. With that said, we are talking about today's topic is more on the V model, V curve model on the Ultra HDI PCB design and how it has the impact on the electronics manufacturing. So please do subscribe to the channel. Please do comment on the comment section in the YouTube so that we know how you are liking it, and if you have any questions, if you want to be a part of the show, please do write to us at globalelectronics1234@gmail.com. Let's continue our discussion and with Mr. Amba Prasad. So welcome back to the show, Mr. Amba Prasad, and after this small break. Yeah, please
Good.
do continue.
So this is right now state of the art, some sort of a cross section of a channel on a regular PCB, PCB to backplane and back to the receiver. And here BGA, we have shown BGA fanouts, we have connector breakouts, and return path continuity or discontinuity, whatever we talk, and via and AC capacitor replacement, and the material I have shown various steps of material at the bottom, material cross section. And see, wherever we see now, for example, the signal starts from the die, it goes to the RDL, redistribution layer, then hits the bump, hits the BGA ball, goes to the wire, come out of the wire to the connector, and again the path, that is the half the path, then the other half is completed when it goes to other PCB. Each transition gives you reflection and signal integrity and timing problems. So this is, even now 90% of the PCBs are done like this, but this won't work for 48 Gbps set of Fridays channels. Go to next slide, please.
Yeah.
Why I showed that before was I wanted to just show that a regular PCB topic. You can be an expert PCB designer, but when it comes to 448 Gbps, you have to start from the learn from the beginning. So that's what it is. Bottom of the V model, you generate test vehicles. Statistical process control is very important. Acceptance criteria has to be upfront, it has to be put. I was telling some time back that the PCB, they have to, the trace width or a cross section, they have to give what was spec'd by the PCB designer. I mean, the OEM or a ODM in this case. Anything which is out of the window is not acceptable. Qualification coupons, embedded ultra high density features, a minimum line width and space, stacked wires, repo, impedance structures. Now, when people do the first time this PCB, they embed the coupons within the business area of the PCB. Let's say they have a channel, and next to the channel, they put the actual coupons. They know in reality, inside what's happening. It's not the coupon is at the edge of the panel or somewhere. So they just put it there. Then metrology plan, cross sections, X-ray, then CT scan for stack alignment, SEM for microwire, forward resistant test. These are all IPC tests. IPC TM650 has got a whole lot of specification how to do this. Okay. Then comes the most interesting part now. SPC dashboards, your statistical process control. Track CP, CPK, and for critical for quality, which is CTQ, and CTF. CTF is the critical for functionality. Many times, these two will conflict. Many companies, it is a never-ending conflict. So generally what happens, if two experts conflict, there'll be a discussion. But if one of them is not an expert, the discussion becomes a conflict. So that's how
So,
it is. The conflict
so
is very much important.
having said that, CTQ versus CTF, we should do a separate session as well.
Yeah, that I'm ready to do that. Not a
Okay,
problem.
okay,
But
okay.
we'll take a use case and just do it. We a lot of
Yes,
use cases we have.
yes, yes,
Yeah.
yes.
Then alignment, registration error, go no go gates, class level criteria tied to design of experiment and SPC outcomes for material feature formation, impedance, reliability, and finish quality before pilot release. This has to be closed. So again, generally it happens when we do a NPI, boards will work, but we transfer it to a mass run, it will not work. But fortunately, the type of PCBs what we are talking here for 448 Gbps channels, we don't do in such bulk numbers. I mean,
Right, right.
yeah, we do in very less quantity, so it is easy to control.
Correct.
Next slide, please.
Yeah, here comes CTQ versus CTF. Okay.
Yeah, CTQ versus CTF. Critical for quality. So actually, I should have put critical for functionality first. But anyway, people say since I'm a designer, I'm always biased about functionality. So let me take quality first. So CTQ. Okay, let's start with critical for function. No problem. We can read always. We can change it. Characteristics essential for the product to work as intended for engineering backbone. It is a must. The digital twin is going to help you a lot in this. Derived from a functional requirements, safety and regulatory constraints, impedance control on a high-speed backplane, connector mating force, thermal dissipation, structural integrity. Now, your board can be power integrity, signal integrity can be very good, but let's say there is a delamination. It is not going
Right,
to work. So
right,
mechanical integrity and thermal integrity after 6 reflow cycles, this is very much important. And then let's
right.
go for critical for quality. So what we have expected in the function, maybe CTF can be the left side of the curve and CTQ can be right side of the curve, whatever. Characteristics that directly impact a customer's perception of quality. So here the customer drives. Okay. It derived from
Okay.
a voice of the customer and translated into measurable specs. I told some time back, if you cannot measure it, don't mention it. It makes no sense. Okay.
Right, right.
Example, surface finish, signal integrity, EMI compliance, cosmetic appearance, reliability metrics. So these are very
Right.
important. Now, surface finish is going to play a very key role here because even after above 100 Gbps, surface finish, solder quality, surface finish quality makes a lot of difference. It can make or break. It can start introducing discontinuity. Next slide, please.
CTQ versus CTF conflicts at bottom of the V curve.
This is the last but one slide. This can
Okay.
be a precursor for our next program. But
Sure, sure.
anyway, DFM, CAM tuning and design rule closure. Now CAM tuning. In fact, a lot of courses I conducted for CAM operators. So CAM operators, they are afraid of designers. And designers, I mean, when cam operator really finds a problem and reflects back also, the designers will say, this is a design issue, don't worry about it. Actually, these two teams have to come together and work. Actually, now a lot of software is available. Third-party softwares are available. In fact, they can even predict the effect of copper balancing on the PCB. They are available. They are available as a service also. So people can use that.
Oh,
Yeah. Constraints management, constraint refinement, feed bottom of the V insights into the rule, your library and your some reusable modules. Minimum pad size, anti-pad clearances, via stacking limits. Via stacking limits, I mean, IPC will not allow, or a aerospace industry will not allow more than 5 layers of stacked via. That means only 4 layers
oh,
you can stack because it's a reliability issue. Aerospace has not come out of that still. They're still there. They want reliability is very much important. Hardware compensation, cam-driven scaling, warpage models for ultra-fine images, codify mask, swell, shrink and drill. But this is not as difficult what was when we tried to do a PCB say some 30 years back because now the image is laser direct on the core. They direct plot it on the core. So So that way this is controllable actually. So, okay. And
Okay.
basically, a semiconductor type of disciplines are coming into ultra high density manufacturing. They are just coming. Impedance libraries update the field forward stacks with the measured copper roughness, edge profiles, and dielectric constraint at a gigahertz band. There are only couple of laminate and prepreg vendors who do the dielectric constant and uh, these kind of electrical properties at various level. They do at megahertz and gigahertz range. Otherwise, generally people will take the lowest value available and they give you a very rosy picture. So this is
Correct.
available, but some OEMs and some PCB companies, they do this for a spectrum of range of gigahertz and they publish the data. So this is available. This is not. This is available. This is for granted. Okay. Assembly interplay, validate the component land patterns, flux cleaning windows, and reflow profiles. Now, there is nothing called as no clean. It has to be cleaned, otherwise it won't work. So no clean is, and many people understood no clean as don't clean. So that is the whole problem. So no clean is, yeah, that's it. It is, cleaning is very much required. Okay.
Yeah.
Next slide, please.
I think we are done.
Yeah, we are done.
Yeah.
So, yeah, coming back to what we are going to talk next, I'm telling you, there is a very interesting CTQ and CTF we are going to continue. There is what is called as a VECS.
Okay.
A slot can be plated, like a through hole, a slot can be plated. Already a couple of PCB fabricators are doing it, and a lot of CAD companies are supporting it. This is a very interesting topic. And
Very nice.
over specification. Over
Very nice.
specification is a problem. When people talk of a V curve to
Yeah.
save themselves, they over specify things.
Yeah.
The slide is not
So,
required. There is no slide. I'm just talking.
yeah, yeah,
So
yeah.
over
Please.
specification. People
Yeah.
over specify. To escape, they over specify and they waste a lot of space, time, money, energy, everything. Okay. Then,
Yeah.
yeah, there is one more interesting topic I want to say. When we
Uh-huh.
talk of digital twin and simulation, there is
Yeah.
industry talks about what is called as a runaway digital twin.
Oh.
Runaway digital twin. This is something like, again, I think people are borrowing ideas from Hindi movies. In Hindi movies, we see there are twins, so they get separated at birth. One becomes generally a police, one becomes a thief. So the runaway digital twin is a thief. They say it's possible. They show that this runaway digital twin, it will give you whatever result you want.
Correct.
Everything.
Correct.
But when the board works, it won't work. So that runaway digital twin, you have to capture it. Otherwise, I think there is a lot of Bollywood EDMs are coming into manufacturing in some form or other. So nice. Yeah, again, thanks to Asrani, 50 years back, he told half on left side, half on right side, and remaining follow me. That is all about V model, I can say, so that people can understand, have some fun on the weekend. So, see you
That's
sometime.
great.
Yeah.
Okay, that's great, Mr. Amba Prasad. Ladies and gentlemen, that was the topic for today, which is October 31st and October 30th, 31st today. And it is a Halloween day today, and here in the United States, which is kind of a fun-filled activities and fun-filled some kind of celebration we have. But yes, global electronics is meant to bring in different topics on electronics manufacturing. By any chance, if you are interested, please do write to us, and please do comment on our comment section how you felt about the today's topic. And if you have any questions, you can ask in the comment section. We can of course get back to you. With that said, please tune in for the next week's topic and with another new topic. And definitely we try to bring in the best that is possible because electronics manufacturing is such a vast topic and also subject itself. It's a never-ending process. It's one life is not enough to cover all the topics of electronics manufacturing, but whatever the best we could, we try to bring in. Thank you very much, Ms. Amba Prasad, for
Yeah, thanks.
your valuable time, and you have a wonderful weekend, and everybody else also have a wonderful weekend, and take care of your health. God bless. Thank you.
Yeah, many wishes for the Halloween. Enjoy. And in Bangalore, Halloween is not generally done. I don't know, it's
Yeah,
restricted to
yeah,
US only. But a lot of marketing companies, hotels, and all, they do all those
they do that. Yeah,
things
yeah,
and stuff. Yeah, yeah, they do. I have
yeah.
a few photographs also. Maybe next time when
Yeah.
you see me in Bangalore, I'll show you.
Thank you very much. Have a great
Yeah,
weekend.
thank you.
Bye now.
Yeah, have a
Bye.
nice weekend. Yeah.
Bye. Bye.